Hi friends, welcome back to session 3 on Lean Six Sigma Green Belt series, and today we are going to discuss a little about real world scenarios from Lean Six Sigma. Before I start the session, let me share with you we are following all these books, ebooks which is available, and if you wanted to share your mail ID or write to us and we will be able to share with you. We are in introduction to Six Sigma. What is Six Sigma? And today we are going to discuss some of the real world examples. You can go through this and share your doubts as well. So before we start, let's understand something known as defects in Lean Six Sigma world. Suppose this is a product, and it can be any product or service, any output which an organization produces. However, when we talk about defects, what can go wrong in this bolt itself, this nut and bolt itself? It can be first the thread which can go wrong, right? The thread may not be proper. The second can be the diameter itself. It can be diameter of this bolt, diameter of this nut, diameter of any of the available volumes here. Also the length itself. The length may or may not be correct. It can be less or more than what is required. This entire length can also be a defect. So there can be issues in everything, right? And all these things we call in Lean Six Sigma world as defects. And this is the defect can also be termed as something which the customer does not want, or something which is beyond customer requirement. Now let's go into a little in depth and try to understand this. The same bolt, for example, was taken 1000 units, and we found after 1000 units there were 130 bolts which were not correct in terms of the length. Either they were minus or plus 1 centimeter or 1 millimeter. The diameter also, about 100 bolts were not perfect as per customer requirement. There are 90 for which the thread was not perfect. It was not the way the customer wanted. The metallic properties of the bolts, when tested for 50, it was found not adequate. The strength also similarly for 90 bolts, when tested for 90 bolts, that it was not perfect. And there are few other defects as well which cannot be clubbed into any of these areas. This is just for a simple understanding for you, but there are more advanced level of studies in this field. When we go ahead, we will learn it. For now, going forward, let's say the per unit, so we had 540 units, and we found that out of 1000 unit, 540 units were defects, right? For our simplification, it is like this. So we had 1000 units, and out of those 540 were defect unit. So the defect per unit comes to 540 divided by 1000. Opportunity for defect, that means in how many ways a defect can occur. If you go back, a length can be the length can go wrong in at least in three different ways. Length of this piece, length of the threads, length of the entire bolt. Only the length can go wrong in three different ways. Similarly, when we consider other defects, we found there were at least 73 opportunity for defects. Now the defect per unit, so out of 540 out of 1000 units, we found 540 defect. That is about 54%, you can say, as per a layman term. Now since we have identified opportunity for defect 27, the defect per unit, this is a new term in Lean Six Sigma world, and now it becomes 0.02. That means for each and every unit there is a chance that it can go wrong 0.02 times, right? That's the opportunity for defect. If we multiply this 0 6.02 by 1 million. In Lean Six Sigma, it is known as defect per million opportunity, and that becomes 20,000. The same thing is shared in terms of sigma levels. We will calculate this thing when we move along, but for simplicity now, for 1 sigma, you should have 6,91,462 defects or more. So that's how it is for 1 sigma. Then 2 sigma, 3 lakhs around. 2 sigma, 3 lakhs around. 3 sigma is 66,000. 4 sigma is 6,210. Similarly, this is for 233 is for 5 sigma, and for 6 sigma we should have only 3.4 defects per million opportunity. Now based on the earlier example, we found 2000 defects, so it will be somewhere around maybe 3.2 odd sigma or something, right? Because it should be between 3 and 4 sigma. Now let's understand most of the processes, whatever you will find in the environment, you will find those are 3 to 4 sigma levels, not more than that. Normally it happens with all the processes. However, there are few industries who actually work on 7 to 8 sigma levels, like the aerospace, entire aviation industry. You will find very less number of accidents happening in aerospace industry, aviation industry, and that's how it runs on a very high sigma level. Similarly, the pharmaceutical industry also, they run on a very high 7 to 8 sigma level with not even one defect per million opportunities, right? So that's a bit about some of the examples from Lean Six Sigma world, and thank you, happy learning. Let's connect again in our next session.